Okay, here's a little review video for the Chapter 9 test coming up here. First couple problems are going to be graphing, so pretty much calculator problem. What I'm asking you to do is make a little table of values. And again, use your calculator to do this. As just a refresher, the first one can go 3 times 1/2 and then caret key to the x power. And you can use the table to come up with the values there. Okay, so if we do that, if we make a little table of values, you should, again, use -2, -1, 0, 1, 2. And we should just recognize that, of course, we're going to start at 3 here. And then as you go to the right, so that one would be a 3. When we put in the exponent of 1, 3 times 1/2 to the first is going to be 3/2, so about 1.5. And basically each time x increases, this thing's going to get cut in half. So it's going to be a little lower. And then as you go to the left, basically the numbers are going to get doubled. Okay, so this is going to become a 6 and a 12, because again, that pattern is the number gets times by 1/2 over and over and over. So you can get a couple accurate points, and that should be your graph. Okay, so this one's exponential decay. The b value was less than 1. Okay, and then same kind of idea for number 2. Again, here's my a value. That's where I'm starting at. And then the b value tells me what I'm doing to it, times it by 2. So for each change in x, this thing's getting doubled. So I would go up to 8, 2 would go up to 16, and as we go to the left, the numbers will get cut in half, the y value. So from 4 down to 2, down to 1, and so on. Okay, so there's your exponential growth. Okay, so those are the graphs. Again, use your calculator. They can really help you out. And make sure you plot a few points accurately. Definitely give me an accurate y-intercept. I need to see that, and then everything else should just kind of work out based on multiplying by the b value. Okay, then a couple equations to solve where the variable is part of the exponent. Remember, sometimes you can write both sides with the same base, and sometimes you can't, and you'd have to use a logarithm. This one looks like I can. I see the base over here is 2, so if I can write this 4, I recognize 4 is 2 to the second power. Okay, so it's 2 to the second power, and then that's still to the third power, equals 2 to the sixth power. And then we have our little rule here of a power to a power. This is really 2 to the 6b power, equals 2 to the 6. Okay, so now both sides are written with the same base of 2, and I can set my exponents equal. 6b has to equal 6. And when you divide both sides by 6, you can solve the equation and get b equals 1. Okay, now number 4 might be a little different. Let's see what we can do. First off, you want to get the exponential by itself, so I'm going to subtract that 1 on both sides. So 2 to the p plus 2.8 is going to equal 68. Okay, now if we try to write 68 as 2 to some power, it's probably not going to happen. Okay, it's probably to some decimal or something. So we can't do it like we did number 3. I can't write these with the same base. So when that happens, we're going to switch to log form. And kind of use our calculators here. So we know it's log, remember here's our base, so log base 2 of 68 is going to equal p plus 2.8. Okay, remember logarithm always equals an exponent. Okay, this was our exponent, so that's what the log equals. And now to figure out this left side of the equation, we can do this on a calculator. So doing this portion right here, if you remember that change of base formula, it's log of 68 in parentheses divided by the log of 2. Okay, and that's going to still equal this p plus 2.8. So let's do the calculator portion, the left side of the equation, just like it's written there. Log 68, close the parenthesis, divide by log of 2. And that should get you around 6.087. Okay, so that equals p plus 2.8. So when we go and subtract our 2.8, we will get our final answer of around 3.287, or if we round it, 3.29 should be your p-value there. Okay, so just don't forget, change the log form, then get your calculator out, and your calculator can do all the logarithms for you. Okay, so that should be your answer to number 4. All right, number 5 and 6, kind of doing what we just did, just kind of changing forms. So with number 5, we're just going to, again, I always start with what's the base. So the base is the little subscript there. So 12 to the second power equals 144. So that's an equivalent equation to what they gave us in log form. We just rewrote it in exponential form. Okay, and then number 6, again, same kind of thing. We're going to change it to log form. So it's the log. Again, get that base figured out. The base is the thing getting raised to the power. We're taking the log of 16, and the log always equals whatever the exponent is. Okay, so that's just simply changing forms. Okay, 7, using the calculator, kind of like the step we did up here in number 4. Okay, log base 2 of 68. Number 7 is the same kind of problem. It's log base 6 of 40. So this is basically saying what power do we have to raise 6 to make it equal 40? Okay, so the trick is, or the change of base formula says take the log of the larger number out here, log of 40, divided by the log of the base. And your calculator can do that for you. So again, log 40, make sure you close that parenthesis after the 40, divide by log 6, and you should get around 2.058. I'm going to round it up, 2.06 would be our answer to that. Okay, so 6 to that power would equal 40. That's kind of what we're saying here. Number 8, the ln, that's the natural log. So if you remember, a regular log on your calculator is a base 10. The natural log, ln, means that the base is e. Okay, so it's saying what power do you raise e to equal 2.6? And luckily there's just a button on your calculator, ln, right below the log button. So this one you can just type straight in, basically ln of 2.6, and it's going to give you an answer of 0.9555. So if we round to about 0.96, would be our answer for number 8. Okay, then moving along to the back, some more equations here. Let's see here, number 9. So we have log base 5 of something equals log base 5 of something else. So it's almost like those log base 5s cancel out because they're the same on both sides. So I'm just going to set the thing we're taking the log of equal to the other thing we're taking the log of. Okay, because again, they're both log base 5. So we can just kind of, it's like canceling those out basically. And we'll just solve that regular equation. Add your 5 to both sides, and then divide by the -2. And there's your answer. Okay, so m would be -14. Okay, number 10, a little different. There's not a log on both sides, so I can't just set r plus 4 equal to 3. Okay, because notice there's no log on the right side. But we can write this in exponential form. That's usually the thing. If you can't solve an equation, change forms on it. This thing is really just saying 3 to the 3rd power has to equal r plus 4. Okay, so we wrote it as an exponential. There's no logs in there anymore. And we know 3 to the 3rd power, 3 times 3 times 3. So that's 27 equals r plus 4. And then if you just subtract your 4 from both sides, we can get our answer. So again, that last step, just a normal equation. So r would be 23. Okay, so again, whenever you're stuck, change forms. It really does help quite a bit. Okay, and sometimes it's the only way to go. Okay, number 11, a little word problem. Some fish in a pond. The number is growing exponentially. In 2014, we were up to 1,723 fish. We started out with 142 fish, and we probably need to come up with some equation to model this here. Okay, so for non-continuous, the next part's going to be for continuous. So the difference here, remember, with continuous, we always use base e. And the equation for down there is going to be y equals a times e to the kt power, while a non-continuous is just going to be y equals a times b to the x power. Okay, so let's get rid of this, and let's start plugging some things in. Okay, so they give us an initial value. Okay, that's going to be your a value. That's when you started. We had 142 fish. Okay, b is what we don't know. What, how much is this growing? What is it getting multiplied by each time? We do know the ending value, 1,723, and we know how long it took to get there. How many times did it grow? From 2009 to 2014, there was 5 years went by, so that's how many times it grew. Okay, so that's our equation. Remember, initial value is always a, the 142. Figure out how many years went by, and then your y value is the the later ending value up here. Okay, so now we got to solve this. So I'm going to divide both sides. Okay, again, b is the thing we want, so let's divide both sides by 142. Okay, so let's calculate that. 1723 divided by 142. So that is 12.1338. Just carry up 3 or 4 decimal places to be safe here. That will equal b to the 5th power. Okay, because that canceled that. And then to solve that for just b, we don't want b to the 5th, we want b to the 1st. So the trick is raise both sides to the 1/5 power. Okay, on a calculator, of course, so you have that 12.1338 in your calculator. Just hit the caret key, exponent, and then in parentheses, 1 divided by 5, and you should get an answer of about 1.647 equals b. Okay, again, make sure that this is in parentheses, the exponent. And now we can write our equation. That's the growth factor. So the amount of fish y will equal the amount we started with times that b value to the x power. And again, x is the number of years since we started in 2009. Okay, so that's saying if it grows each year a certain amount. Okay, part B, what if we assume it's just continuous, so it's not just going to jump from one number to the next number at the end of the year, it's going to kind of gradually go through, which is more likely and more realistic. So let's do it that way. It's the same basic setup, except we need to find this k value here. Okay, we're going to use e as the base. Anything continuous has a base of e. But the rest of the problem is pretty similar. Let's plug the numbers in. The y value is still the ending 1723. We still started with the 142 for A. Again, E is like around 2.718. It's that decimal that we talked about before. K is the thing we don't know, but we know T here. T is just like X. It was 5 years. So K times T, I'm just going to write the 5 first, is 5 times K, because again, it's 5 years. And we're going to go through some of the same steps. We're going to divide by 142, just like we did before, so we kind of already know that answer. To the first step, when we divide by 142, that's where we got the 12.1338. Okay, but in this case it equals e to the 5k power. Okay, so here's an equation we need to solve. The variable is an exponent. Go to log form. Okay, so we're going to change this to log form. The base is e. The thing we're taking the log of is the 12.1338, and it always equals the exponent. Okay, so I'm going to need a little space here. Now log base e, that's that natural log I was talking about. So let's rewrite that. That's the ln of 12.1338. Okay, and again, your calculator knows what that is. So if we want to solve that for k, we can just divide both sides by 5. Okay, and make sure that's in parentheses. So this will get us k. I'm going to do the natural log of 12.1338. Close that parenthesis. I know I say that every time. Make sure you do. And then divide by 5. That'll get you a k value of about 0.499. Okay, and that will allow us to write our equation. Y is going to equal, what do we start with, 142 times e to the 0.499 t. Okay, and again, t is the number of years that go by since we started, which was in 2009. Okay, so if we want to make a prediction now in part C, using the equation we just got, how many fish would we expect in the year 2018? Okay, so that's 9 years since we started. Remember, we started in 2009. So all I'm going to do is take that 9, throw that in for t, and calculate this out. So the number of fish will be the 142 times e to the 0.499 times 9. Okay, so let's calculate that out. 142, there is an e to the x button on your calculator. It's right above the ln button. Okay, or of course you can use the 2.718. And then the exponent on the e needs to be 0.499 times 9. And I'm getting a value of around 12,667.9. Okay, so let's just say it's an approximate. We're not going to get 0.9 of a fish, hopefully. Um, so we approximate that many fish. Okay, and last one, a little interest problem, gaining interest in a bank account. Um, this one, they're calculating your interest daily, so it's not a continuous case. If it's continuous, it'll just say the word continuous, and that's when you'd use the E formula. But in this one, it's not. If you remember the formula here, the amount is going to equal the amount you start with, the principal, 1 plus R over N to the N times T power. Okay, so this was a couple sections back. That formula was given. So after 6 years, how much would we have? Okay, so let's start plugging everything in. Okay, the principal, we're starting with 2,300. 1 plus the rate. Okay, convert that to a decimal, 0.0365. Okay, if it's compounded every day, and then the number of times per year is 365. That's your N value. That's the N out here also for 6 years. Okay, so this is kind of a long calculator process. I like to break it up into steps. I would personally do this piece first. Okay, so 1 plus 0.0365 over 365, so that's giving me like 1.0001. And the next thing I would do, following order of operations, is raise it to this power. So raise it to the power of 365 times 6. So now I'm at about 1.2448. And then finally that can get multiplied by the 2300. Okay, so I like to break it up into 3 steps. If you get the same answer, you do it however you want, but I got $2,863.08. Okay, if you didn't get that, break it up into smaller steps. Okay, a way to kind of make sure it seems reasonable too, look at what we started with. We started with $2,300. Okay, and we're earning a fairly small percentage, so 2,800 as a final answer seems reasonable to me. If you ended up with like $1 million or something would probably be off. So just make sure you end up with a little more than you started with, and you should be confident that's right. Okay, so let's say you need to get up to $8,000. How long is it going to take? So let's say from when you first put the money in. So we want the ending amount to be 8,000. Okay, that's going to equal, I'm using the same formula. We started with the 2,300, still the same 1 plus the rate over N. Okay, the exponent now, we know N, but the thing we want to know is how long is it going to take. Okay, so that's going to be our T value. That's our variable here. Okay, so let's start doing some work here. We got to solve for T. I would first divide both sides by 2,300. Okay, so if we divide both sides by the 2,300, okay, so that's basically gone. This side's giving me about 3.478. Okay, and again, don't round that too short, at least 3 decimal places. Inside of here, I know we did that before. I think that was 1.0001. Okay, but verify that on the calculator. So I'm just doing like kind of step-by-step simplifying here. Okay, now we're ready to change to log form. I want to solve for an exponent. I'm going to log form. So log form would say the log of the base is the 1.001, log base 1.0001 of 3.478 has to equal 365t. Okay, so that was just switching log form. Now this piece is a calculator problem, change of base formula. We did some of those on the front. Let's do the log of the 3.478 divided by the log of the 1.0001. Okay, so that piece gives me around 12,465.947. I know that equals 365t, so my last step is just simply divide by 365. And we will get our amount of time, which is rounded to the nearest tenth, about 34.1 years. Okay, so it's going to take a long time, but think about it, it's free money. You throw money in a bank account 34 years later, you've more than tripled your money. So Okay, so again, when in doubt on these, change the log form. Um, make sure we get this formula down and known for the compound interest. That's the only time you'll use this formula is compound interest. The other problems are just kind of more of the basic y equals a times b to the x and y equals um, a times e to the kt. Okay, so that is that. Hopefully that helps. And the test you guys will see will be very, 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 very similar. All right.